Hello class 10. Today I am going to explain the chapter machine to you in physics. So in machines, first of all, I have to explain what do you mean by pulley. Pulley is a kind of a simple machine that is having a rope and a grooved rim in which a rope is attached, and just like that, this kind of the pulley that we are using in a well to take out the water from it by using a bucket. Okay, so this type of the pulley we are using, that is a kind of the single pulley. So class, pulley is a kind of a simple machine that consists of a rope and a wheel and is used to change the direction of the effort or a force. So today I am going to explain a single fixed pulley to you. A pulley is having three types: a single fixed pulley, a single movable pulley, and a block and tackle system. So first of all, I have to explain about the single fixed pulley today. So students, here the single fixed pulley is written. In a single fixed pulley, that is the diagram of the single fixed pulley. Single fixed pulley is used to, I have told you, to take out the water from the bucket. Okay, that pulley is also used for a flag hoisting. Okay, so any kind of if where you have to change the direction of the force, wherever you have to change the direction of the force, only you have to use this single fixed pulley. Got it? So have a look here on this diagram. Here the tension and a effort and a load is written. I'm going to explain this diagram to you, because this is your fixed support. This is your fixed support. Okay, and that is your axle. In this, a pulley is arranged. In this, a pulley is arranged on a wheel, and this is your rope. This is your wheel. On a wheel, a rope is attached, and considering that this rope is and a wheel we have taken as a massless. Got it? So if we have taken it as a massless, then what will be happen? Listen, effort is applied on that. How you are applying the effort? Suppose that here is the load. Load is attached to this pulley, and load is having a gravitational force. That's why the load is coming downward. So if the load is coming downward, then the opposite force, a tension force, will act on the body. So here you can see that a T is written, that is a tension force on that body. So if tension is caused, listen, and effort will be applied on the another side to pull it. Okay, to pull it up, this load, effort will be applied. So if you are applying the effort, then the tension force will also be applied. So have a look here. The load which you have applied, the load is given to you, and the tension force which is acting, both are opposite in direction and they are having the equal magnitude. Got it? And just like that, effort and this tension force is also having in opposite, also are in opposite direction and having an equal magnitude. That's why we have written L is equal to T and E is equal to T, because we have taken as a pulley and considering as a pulley and rope as a massless quantity. So listen, here I have written force multiplier and a speed multiplier. So firstly I have to check that this works on a force multiplier or not. So in the case of a force multiplier, first one I have to tell you, first thing I have to tell you, that a mechanical advantage should be greater than 1. For a force multiplier, a mechanical advantage should be greater than 1. So I have to check that the mechanical advantage is greater than 1 or not, or less than 1. Okay, so the formula of a mechanical advantage is load and effort, load by effort. So what is the load? Listen, load is just like the tension on the body. So we have applied here T by T, and T by T, that is the force. Now L is equal to T. That's why we have written, in place of L we have written T, and in place of E we have written T also. and this t will cancel, and this will give you the mechanical advantage 1. Listen, if the mechanical advantage is 1, that means this is not a kind of the force multiplier class. Okay, because if you have to multiply a force, the mechanical advantage should be greater than 1. Why the mechanical advantage should be greater than 1? Listen, here you are applying the force, effort. Here you are applying a effort. Effort is also a kind of the force. So listen, if the effort is greater, then the mechanical advantage will be lesser, because they are inversely proportional to each other. So if the effort will be greater, then the mechanical advantage will be lesser. Just like that, you are taking a fraction, and if the numerator part is lesser than the denominator part, that means denominator is greater. So what will happen? If the denominator will greater, then the answer will come lesser than 1. And if the denominator part is lesser than the numerator, then what will happen? It will be greater than 1. So we have to make this effort, less than the load. But whenever you are applying a force on an object, you would require a less effort. You want a less effort to apply. That's why they are called as a good machine. So that's why force multiplier it is called as. Okay, वो क्या कहलाता है? Force multiplier कहलाता है. So effort should be lesser. अगर effort less हो जाएगी तो mechanical advantage 1 से greater होगा. That means 2, 3 approximately that you will get according to your values. So here we have proved that a force multiplier, it is not the case of the force multiplier. Now I have to check speed multiplier. This speed multiplier, in the case of the speed multiplier, I have written as the mechanical advantage should be less than 1. So we have to check the mechanical advantage is less than 1 or not. So listen, velocity ratio, that means VE by VL we have taken. Okay, the velocity of the effort by the velocity of the load. So here we have to check. So listen, suppose that we are applying the effort on this particular direction, just like that. If we are going to apply an effort for a 1 second, it moves a distance of a x meter. Got it? If we have applied a effort for a 1 second, we have applied, this will move x distance. So if this rope moves moving a x distance, then load will also move x. The same distance will be applied because this load will come upward. So that's why we have written, beta, what is the formula for velocity ratio? Velocity, displacement by time. And what kind of the displacement we have given to you? Tell me. X. And what is the time? By 1. So that the formula will be applied now. VE ke liye. For a VE, listen, for a VE, what we have applied? X by 1. Just like that, in the same manner, for a VL also, this will move upward. That means x meter by 1. That will be divided by 1. So x by 1, VL also x by 1 and x by 1. We have written here. So x by 1 and x by 1 we have written. That's why it is coming as x by x. Got it? I have filled this board already for you. That will give you x by 1 and x by 1. This and this will be cancelled. So the velocity ratio will become 1. So that's why we have proved this is not a case of the speed multiplier also. If the velocity, the displacement moved by the load and the effort both will be same, so what will be the need of the machine? This is not the case of the speed multiplier. This is not the case of a force multiplier. So why we are using a single fixed pulley class? We are using a single fixed pulley for change in a direction of the effort. We are using a single fixed pulley for changing a direction of effort. So why we are using in changing the direction of effort? Listen, if you will not change the direction of the effort, how you will pull up the water from the bucket, from a well? कैसे निकालोगे पानी? ऐसे इस तरीके से कुछ फोर्स लगा करके आप वाटर को ऊपर खींचेंगे. गॉट इट? सो For that, for your convenience, you have to change the direction of your effort. For this only, we are using a single fixed pulley class. Got it? For this only, this is not the case of the force multiplier, this is not the case of a speed multiplier, this is only a case of a change in a direction of effort. Got it? Only we are applying for this. Its mechanical advantage is 1, its velocity ratio is 1. Class, have a look. One thing I have also written here, mechanical advantage is equal to 1. We have proved this. If the mechanical advantage is equal to 1, that means it is an ideal machine. Whatever the work you have input, you are getting the same output. जितना काम आपने किया उतना ही आउटपुट आपको मिल रहा है उसमें से. That means mechanical advantage is equal to 1. That means this one is an ideal machine. Ideal machine, that means efficiency is equal to 100% class. The work output and the work input should be same. So every machine, it is not possible. That is not possible to get a 100% efficiency just because of the friction. Frictional force will take your effort. जितना भी आप उस पर एफर्ट लगाएंगे, फ्रिक्शनल फोर्स थोड़ा सा उसको लेस कर देगा. सो मैकेनिकल एडवांटेज इज इक्वल टू 1, आइडियल एंड ये जो एफिशिएंसी है वो 100% है. हाउ इज इट पॉसिबल? बिकॉज वी हैव टेकन दिस पुली, okay, this rope and the pulley, that is a grooved rim, massless. That's why this efficiency is given to you 100%. Now velocity ratio is 1, that always 1. For a single pole fixed pulley, that velocity ratio will always be 1, because however you are applying the force, जितना force आप लगाएंगे, effort will move the same distance as the load will move. Okay, so the velocity ratio, that means VE by VL, will be the same. That's why the velocity ratio will always be 1. Class. For an ideal efficiency is 100%. For a practical efficiency is less than 100%. Okay, it may be 60%, 40%, 30%, according to your machine power, machine efficiency. So here you can see that the formula we have written, mechanical advantage. The mechanical advantage is equal to efficiency into velocity ratio. In this formula, we will put the efficiency of a machine. Suppose that your machine is having the 90% efficient machine. So for 90% efficient machine, what we will do? We will write that is the relation between efficiency, mechanical advantage and velocity ratio. So in a mechanical advantage, efficiency is given 90 by 100, that will be a fraction, percentage will be multiplied by 1, because I have told you the velocity ratio is equal to 1. I have already proved this. And if this will be multiplied, this will give you 0.9. Okay, after cancelling we will get 0.9. And if we will take 80% efficiency, the mechanical advantage will be 80 by 100, that will give you 0.8. So here you can see that the mechanical advantage which you are getting, that is lesser than 1. Okay, the mechanical advantage is, that means lesser than 1. So यहाँ पे आपके पास क्या है, इसकी 100% efficiency नहीं होगी. That this one is not having a 100% efficiency. So that is your single fixed pulley. In the next video, I will explain you about single movable pulley. Thank you for class.